Of Math 7 5.4, Understanding Inverse Proportion. As promised, I'm making a video with my hoarse throat, so I apologize for how it sounds. Hopefully you can understand me. We're going to start back up on page 280 of the book, where we are using a graph to interpret inverse proportion. So, in order to use a graph to interpret inverse proportion, it's going to be a little bit different than a direct proportion graph. So instead of being straight, the inverse proportion graph, it is curved. So remember, direct was a straight line. Well, indirect is a curved line. So we have our table of values here for x and y. The example it gives us is example 4, the number of card game cards each student gets. Y is inverse proportional to the number of students sharing 120 game cards. X, the graph shows the relationship. So x and y, 1, 120, 2, 60, 3, 40. If we draw out a graph for those, and these are the game cards, so y, these are the students, so x, we have to graph these. Now we could say 1, 2, and 3. Up here we need to go all the way up to 120. So here is 0, about middle is 60, and we could go between 60 and 120. So we could say 80, 100, 40, 20, and 0. Perfect. Now let's graph this. So when it's 1, it's all the way up at 120. When it's 2, it is down to 60, and when it is 3, it's down to 40. So as you can see, straight line would not go through that. Either way would miss some points. So what you actually get is a curve a little bit steeper than what I drew the first time. And that curve that you get, that is your inverse proportional line. Okay, so we could keep putting in values of x to get y based on our equation, and you could get more and more and more. Let's try an example. 13. It gives us a graph, so we're going to interpret it. The time it takes to clean the windows in an office building is inversely proportional to the number of window cleaners. The graph shows the amount of time, y hours, it takes x window cleaners to clean the windows. Here it is. They gave us 1 point. Find the constant proportionality graphically, then write the inverse proportion equation. So remember, inverse proportion, to find the constant proportionality, we'd figure out k, which equals x times y. So in our graph, we know the point 2, 12, separate from that. So remember, the 2 is the x, the 12 is the y. So in k, we could say 2 times 12, which is equal to 24, and that is the answer. B says explain what the point 212 represents in this situation. And what it means, the x-axis, the one going this way, says the number of window cleaners. So it goes over 2. That must mean that it takes 2 window cleaners, and then 2 window cleaners what? Well, y is the number of hours. So it goes up on the y, 12. So it must be 2 window cleaners, 12 hours to finish. Okay? Try that on guided practice. 5. Next thing we're going to do is we're going to solve. So you've learned to write and solve them. You've also learned to translate them. Now you can write this inverse proportion equation yourself to find a no value. For example, y is inversely proportional to x. This is example 14, by the way. Y is inversely proportional to x. So we know that k equals xy, because that's inverse. Now, y is 20, x equals 8. So A says k equals what? Well, k equals x times y. So it's going to equal xy, 820, 160. That's constant proportionality. B, write an inverse proportional equation that relates x and y. So we want to also have something that includes x and y in the equation. So right now we have this. If we want x and y included in the equation, the only other number we can enter in is k. Do we know k? Yes. So therefore we can write 160 equals xy. And that's a good relationship for them. Now, C says find the value of y when x equals 5. So x equals 5. Y we don't know. We do know that 160 equals x times y. So we don't know y, but we know x, so we can put x in. So x becomes 5. There's the equation we know. Let's get y alone by dividing both sides by 5. Those cancel. So we substitute first. 2, divide. 3, simplify. 160 divided by 5 happens to be 32. So y is going to be equal to 32 in this situation. Try that on guided practice 6. Last example, solve a real-world inverse proportion problem. Awesome. An auto repair garage with a total number of hours y it takes to repair a car is inversely proportional to the number of workers, x. We know they are inversely proportional. So we know that k equals xy. We defined our variables. Y is hours, x is workers. This is our equation. So our constant proportionality, k, start by finding that, is going to be equal to whatever that is times that is. So the problem tells us it takes 2 workers 6 hours to repair a car. So 2 workers, that's x. 6 hours, so y must equal 6. So we can put these into the equation. Constant proportionality equals 12. Now, we're trying to figure out how long will it take 4 workers to repair the same car if they work at the same rate. So x is going to be equal to 4 because we know 4 workers. Y is what we want to know. So if we know this equation, we've written it out, k equals this. We could translate that into k just 12 equals xy. They're related now. 12 equals xy. Like we did up here, we made our equation. Follow these same steps. We say 12 equals xy. Now, we put these formulas in, we do these 3 steps, substitute. So 12 equals 4y, divide, and simplify. Okay, we've done all that. So now we know that it takes 4 workers 3 hours to repair a car. Let's go back to your equation, see what the question is, make sure we answered it. We got it. Try that on guided practice 7. And that is all there is for today.